In this activity, we will investigate unicast, broadcast, and multicast traffic. So as you can see from the screen, this is a typical network, and we're gonna try to generate unicast traffic and then broadcast traffic and then multicast traffic. So in order to generate unicast traffic, I will click on PC1, go to the desktop tab, and then click command prompt. So I'm gonna write a ping command and write the IP address 10.0.3.2. Then I'm gonna go to the simulation mode. As you can see, this is the real time right now, and we need to go to the simulation mode to see in details what type of traffic basically happens when you execute a ping command. I just press this capture and forward. You see a lot of EIGRP packets are being transmitted between the routers and PCs. So here you see an ICMP packet. So an ICMP, basically when you execute a ping command, it basically generates an ICMP packet. If you click on this ICMP, you'll see the source address is 10.0.1.2 and the destination is 10.0.3.2, which we wrote in the ping command. All right. You'll see the so the PC from PC1 it went to switch. All right. Okay. So as you can see, from PC it went to switch and then to router 1 and then router 3 and then again to router 1. All right. So in layers you can see the layer 3 IP header information. And over here in the out layers, you can also see the layer 3 IP header information. And it also shows you the description of what basically happens when a router receives the packet. The packet is an ICMP packet. So we have seen how to generate a unicast traffic from PC1 to router 3. Okay, because PC1, when you write the ping command, it generates an ICMP echo request all the way to router 3, and then it basically sends back the echo reply message to PC1. All right, so now let's generate a broadcast traffic. For that, we need to basically add a complex PDU. Over here, so you can see add complex PDU. When I click on it, I go here, and now I have to select where I want to basically generate this PDU. So PC1, if I click on PC1 is going to be the source to generate the broadcast traffic. So I clicked on PC1. Now in the destination IP address, I have to write the broadcast address 255.255.255.255. Sequence number is going to be 1, and one shot time is 0. And then I'll again click on capture and forward. So you see over here, so it goes to switch again, capture and forward. Now it has broadcasted to PC2, PC3, and router 1. And router 1 has sent it back to switch, right? And switch has sent it back to PC1. Now notice router 1 did not broadcast this PDU to router 2 and router 3. And I hope you already know the reason for it, because routers, they basically avoid the collision, the broadcast domain. They divide the broadcast domain. So router do not forward the broadcast packets to all of their interfaces. So this is the reason this router 1 did not forward the packets to router 2 and eventually router 3. So that's how we generated the broadcast traffic. Now we are going to generate the multicast traffic. And for that, it was already generated. Yeah, see, EIGRP. So the Cisco EIGRP protocol, basic routing protocol, basically, runs by exchanging packets among the routers. And those packets basically are sent using a multicast address. So as you can see, the source IP is 10.0.2.1. This is the IP of router 1, and the destination IP is 224.0.0.10. This is the multicast address. So this is how the EIGRP protocol works. As you can see in the description, the destination IP address is a broadcast or a multicast address. The device sets the destination address as the next hop. All right. So and you can also look into other EIGRP packets that are sent or communicated among these routers. So this is how you basically investigate or generate the multicast traffic.